Consortium Enviro Solutions.
Municipal sewage treatment can be described as predictable. You know what type of wastewater is coming, when it's coming, and how to handle it. But treating industrial wastewater is a whole different story. It's unpredictable, it's highly variable, and if you get it wrong, the consequences can be serious. There are many well-known challenges when it comes to designing an efficient wastewater treatment plant, but today we will focus on wastewater composition and its hidden threats. Industrial processes often run in batches, not in continuous flows. CIP operations, cleaning cycles, and production changes can all trigger sudden peaks in pH, in salinity, or in chemical oxygen demand. These events can throw an entire treatment system off balance, especially if there's no equalization. Additionally, if the volume of incoming wastewater exceeds the plant's design capacity, it can overwhelm downstream filters, causing blockages. Total suspended solids particles can physically clog screens, pumps, and pipes, leading to increased maintenance and potential equipment failure. Furthermore, a high load of organic TSS directly increases the volume of sludge that the plant must handle, process, and dispose of, this driving up operational costs. On the other hand, total dissolved solids, TDS, such as chloride, sulfates, sodium, and calcium, wages biochemical war. It creates a hypertonic environment, causing the bacteria to dehydrate, which reduces their ability to treat pollutants and can ultimately lead to cell death. Fats, oils, and grease are one of the most common and destructive components of industrial wastewater. If the fog manages to reach the treatment plant, it disrupts the biological process in multiple ways. 1. Starving the aerobic bacteria that are essential for treatment. 2. Suffocating the individual microbial flocks and preventing them from accessing the BOD they are supposed to consume. And 3. Promoting the growth of specific types of problematic filamentous bacteria which can cause bulking, resulting in high levels of suspended solids being discharged. Some organic compounds are recalcitrant, which means that they are resistant to biological treatment and slow to degrade. A high COD to BOD ratio is often a warning sign, and there are surfactants which reduce surface tension, produce foaming, and interfere with separation processes like flotation and settling. If left unchecked, they can seriously impact performance across the entire system. High concentrations of nutrients such as nitrogen and phosphorus or toxins like solvents, cleaners, and industrial additives can act as inhibitors, poisoning the biomass and bringing the entire process to a halt. Having a full inventory of chemicals used on site is essential to spotting these threats before they hit the reactor. Heavy metal can trigger a cascade of failures with severe downstream consequences. The initial interaction occurs within the biological reactor, where metals disrupt critical life functions of the microorganisms, causing the widespread death or incapacitation of the biomass, which brings the biological treatment process to a grinding halt. The second-order consequence is the contamination of the plant's sludge. Therefore, a single industrial discharge of heavy metals transforms the plant's primary byproduct from a potential viable resource into a long-term, high-cost liability. The core problem with PFAS is their combination of persistence, mobility, and bioaccumulation. As discharge permits are updated to include strict PFAS limits, the utility becomes legally and financially responsible for removing a chemical that its existing infrastructure was never designed to handle. This transforms a water pollution problem into a complex and expensive waste management problem. The silent upset temperature is a master variable that controls the kinetics, physics, and biology of the entire system, making thermal pollution a silent but potent threat. Without continuous temperature monitoring of the effluent, operators could waste precious time and resources searching for a chemical poison, ordering expensive toxicity tests, and implementing incorrect corrective actions, all while the true culprit is simply a slug of hot water. The serious consequences mentioned in this video are not abstract. They are codified in law and carry severe financial and legal penalties. Each of these violations can result in significant consequences, including mandatory compliance orders, substantial daily potential citizen lawsuits, and reputational damage. So how do you design a system that works? It starts with proper wastewater characterization. Concept engineering and pilot testing are essential to verify that a specific technology or process will work for a particular water source before full-scale implementation. Selecting the right construction materials is also crucial to avoid corrosion, unplanned shutdowns, or catastrophic failures. Only then can you engineer a solution with the right materials, technologies, and safeguards that will deliver the expected performance even in the worst case scenario. At Consortium Enviro Solutions, we specialize in the treatment of complex, variable, and high-risk wastewater streams. providing efficient solutions for even the most demanding industrial challenges.
Consortium Enviro Solutions.